Okay, today we are going over our homework for 514, CC1 514 review and preview. We're going to start with problem number 34. Complete the diagram below and write the multiplication problem and answer that would go with it. So I have 4 and 1/5. That's part of my multiplication problem. So that's one of my factors, 4 and 1/5. Okay. Now I know that my second number is a mixed number and my fraction's 2/3. I do need to figure out what is this number. Okay. In order to do that, I could say, well, what is 12 divided by 4? So I'm going to write that here. The answer is going to be 3. So it's 4 and 1/5 times 3 and 2/3. Well, now I have to complete my generic rectangle and find the answer, the product. So 3 times 1/5. 3 times 1 is 3. 1 times 5 is 5. Okay. 4 times 2/3 is 8/3. And 1/5 times 2/3. 1 times 2 is 2. 5 times 3 is 15. Now I'm going to add everything together. So I have 12 plus 3/5 plus 8/3 plus 2/15. Now remember, when I'm adding fractions, I need that common denominator. We decided in class, my denominator down here in this corner, that's going to be my common denominator. So I already know that it's 15. I'm going to take 8/3, use a giant 1, equals something out of 15. 3 times 5 is 15. 8 times 5 is 40. I have 3/5. Again, my common denominator is 15. 5 times 3 is 15. 3 times 3 is 9. Okay. Once I get here, I'm going to add my fractions together. So I have 9 plus 40 plus 2. So 40 plus 9 is 49. 50, 51. It's 12 plus 51/15. But this number here is still an improper fraction, so I want to make that not an improper fraction. So 51/15. 15 goes into 51 3 times. 3 times 15 is 45. 51 minus 45 is 6. So it's 3 and 6/15. Okay. So it's 12 plus 3 and 6/15, which is 15 and 6/15. But 6/15 I can simplify. I can simplify by 3. 6 divided by 3 is 2. 15 divided by 3 is 5. It's 15 and 2/5. That is my answer. Okay, problem 35. Draw a rectangle. Okay, so I'm going to draw a rectangle. I'm going to make this rectangle 4 high and 8 long. Okay, label the lengths of the sides. I already did that. enlarge it so that the ratio of sides of your new rectangle to the old one is 5:2. What are the new dimensions? Well, I'm going to take 8. I'm going to multiply it by my ratio, 5:2. So 8 times 5 is 40. 1 times 2 is 2. 40 divided by 2 is 20. I'm going to do the same thing with 4. My new to old. So 4 times 5 is 20. 1 times 2 is 2. 20 divided by 2 is 10. So my new rectangle is going to be 10 high. 2, 3, 4, 5, 6, 7, 8, 9, 10. By 20, I'm going to turn my paper sideways. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is my new rectangle. It will be 20 by 10 centimeters. On the other side, problem 36. When making estimates, it is sometimes useful to approximate unfamiliar fractions by comparing them to numbers that are more familiar to you. Label each dot with one of the fractions from the list given below. Okay. So if I'm labeling my fractions, I need to kind of look at all of them before I answer, because there's a lot of fractions there. Okay. So I have 1/12, 7/6, 13/12, 15/9, 6/100, 6/7, 30/16, 2/17, 12/25, 2/20, 98/100, 6/11, 6/5, 4/2, 20/11. Okay. So what I'm going to do is I'm going to go through and I'm going to make sure that none of them have the same numerator and denominator. And they don't. But I do see one here, 4/2. That's 4 divided by 2. That's 2. So above the 2 is 4/2. Okay. So if that's the case, then I can kind of work from there. So there's this one right here that's really close to the 1 or 100, 98/100. Okay. Now I know 7/6, 13/12, and there's one more, 6/5 right there. Those are all pretty close to 1. They're just over 1. I just kind of have to figure out, well, where are they at? 13/12 is going to come first because my denominator's larger, so that means it's going to be smaller. And then 7/6, and then 6/5. It goes in order of the size of the denominator. Okay, so I've done those. Okay. Now I can do the other one that's close to 1, 6/7. 30/16, that's like more than 1. So I still have 3 more that are more than 1. So I have 30 sixteenths, 15 ninths, and 20 elevenths. So same thing. I'm going to start with 30 sixteenths down here because the denominator is larger. 20 elevenths and 15 ninths. Okay, those ones are all done. Which leaves the middle ones. So it's not going to be 1/12 or 6/100ths, but it could be 12 25ths or 6 11ths. So 12 25ths, 6 11ths. Now I'm going to do this cluster here. Okay, so I have 6/100ths. That's going to be my smallest value. Okay. Then I'm going to put 1/12, then 2/20ths, and then 2/17ths. Okay, part B, which of these fractions are greater than or equal to 1.5? Okay, well, I'm gonna find my halfway point. It's these 4 right here. So I have 15 ninths, 20 elevenths, 30 sixteenths, and 4 halves. Which fractions are close to the number of 1, or the number 1? I have 6/7, 98 over 100, 13/12, 6/5. Which of these fractions are close to 1/2? I have 2 of them. 12 25ths, 6 11ths. Which ones are close to 0? That's this cluster down here. So 6 100ths, 1/12, 2 20ths, 2 17ths. Okay. Problem 37. Richard's strategy for changing a percent to a decimal is to put the decimal point in front of the percent number. An example of his work is shown at right. Do you agree with Richard's method? Explain your reasoning. Okay. With this, okay, I'm going to look at my percent and okay, 8%. He's saying, well, this is 8/10, but it's not 8%. If you remember, we had our grid, our 100% grid, or yeah, our 100% grid. Okay, and my picture is going to be awful, but you get the point. So 1% was one of these squares. So if I have 8%, it shouldn't be 8/10, it should be 8/100 because each box is a 100th. Okay, 80%, well, this one's right. 80% is 80/10. So if one whole row was my 10ths place value, then yeah, this would make sense. 800%, it's still saying it's the same. These are all the same number here. That one won't work. 800% should be this number. It's 8. So no, I do not agree because each number must be placed according to the number of tenths, hundredths, or etc. that he needs. So do not agree because I just spelled that wrong. Because the 8 in each number must be placed according to the number of tenths, hundredths, etc. that he needs. Okay. Divide each pair of numbers below. 75 divided by 10. So 75 divided by 10. 10 goes into 7 0 times. 10 goes into 75 7 times. I can add a decimal, bring down my 0. 10 goes into 50 5 times, and I bring my decimal up. So this is 7.5. 75 divided by 100. 100 goes into 7 0 times. 100 goes into 75 0 times. 100 goes into 757 times. 700. Add a 0, drop it down. 100 goes into 500 5 times. Bring my decimal up. 0.75. And then 75 divided by 1,000. 1,000 goes into 7 0 times. Goes into 5 0 times. Add a decimal, goes into 750 0 times. Goes into 7,500 7 times. Just 7,000. Means I have 500 left over. I add a 0, drop it down. 1,000 goes into 5,000 5 times. Bring my decimal up. Describe in words what happens to the decimal point in each problem. My decimal point is moving to the left. So on our homework from last week, we were multiplying and the movement went to the right. If I'm dividing, the movement goes to the left. As always, if you have any questions, please don't hesitate to reach out.